Okay, number 5 on the homework describes a problem like this. There's a proton here right at the origin of a coordinate system going down this way with some speed v, and the v that's reported in this problem here is 1 times 10 to the 7th meters per second. So the proton's humming along down that way. And what the problem asks for, it wants to know what the magnetic field is that the proton generates at point 1, point 2, and point 3. So there's 3 points here. So right at the instant it passes the origin with this speed, what magnetic fields is it producing here, here, and here. The formula that we're going to use for this is sort of this point form of the biot savart law here, which I have written here, mu naught over 4 pi, qv sine theta over r squared. So you have this force law here. The funny thing about this force law is it involves this angle here, which is the angle always between the velocity of the charge and its distance back to its point where you're curious about what the magnetic field is. So for instance, if I go to point 1 right here, I know that the velocity is down this way. That's that purple arrow right here. And I know that the distance back to point 1, or to the observation point, is along this line right here. And if I look at it, if v is down and r is going straight up this way, the angle between r and v is 180 degrees, and the sine of 180 is 0. So without doing any further calculations, I can conclude that the magnetic field of point 1 here is equal to 0. You can conclude the same thing about point 3 because the only difference between the problems is, yes, point 3 is being approached by the proton at this point, but the v of the proton is still downwards like that, and the distance from the proton to the point of question here is right here. Something down like this. I kind of drew that crooked, but it's sort of down like that. So the angle between the v and the r, in this case here, is 0 degrees. And the sine of 0 is 0. So the magnetic field of point 3, just by these angular arguments, is also 0. So there doesn't appear to be any magnetic field along the y-axis at all, because all of those points have an angle which is either 0 or 180 degrees relative to the velocity of the proton, the direction of the velocity of the proton, the direction of the speed, however you want to say it. Now point 2, of course, is a bit different out here. That's where you want the magnetic field here, because it's sort of out here at 90 degrees. In other words, the proton is still going down this way. Its v is still down along the negative y-axis, but the point is out here along the x-axis. There is a 90-degree angle now between the v of the proton and the observation point, and the sine of 90 is 1. So you will have a bit of formula here which does not cancel out on account of the sine being a 0. So 4 pi, in fact the sine is going to be 1, qv over r squared. And so now you're in the situation now of just more or less just filling in the numbers. The mu naught over 4 pi is just a constant which you can look up here. The q is going to be the charge on the proton, 1.6 times 10 to the minus 19 coulombs, something like that. The v is given in the problem here, 1 times 10 to the 7th meters per second. You have that, and you divide the whole thing by now the distance between the proton and the field point, which looks like it's going to be this distance right here, or 1 centimeter. 1 times 10 to the minus 2 meters, to make sure it's in SI units, and it is squared down there, so it's going to be something like that. You can put all this together here to sort of arrive at your answer, but the magnetic field then, or the B at point 2, is going to be something like 1.6 times 10 to the minus 15 Tesla. That's the answer I get for that one.